Alright guys, so for this last week before like our finals week or whatever, we're going to talk about graphing square root functions and cube root functions. So normally I would have you do like a lab where you're graphing them and looking at how they change. So I'm going to do like an abbreviated version of that sort of on Desmos. So we're first going to take a look at our square root function, and the most basic way that you can have a square root function is where you're just taking the square root of x and nothing has been changed. So like if you're on Desmos, you can pull up the keyboard down here and get your square root, type that in, and then we can put x. And so this is what the basic shape of that function is. So some things to notice. This graph kind of only goes in one direction. It's sort of starting at 0, 0 right here and only going up and to the right, like that. So it has like a strict starting point and it never goes past that point. It only goes in one direction from that point, which is pretty unique because most graphs like are continuous and they go in both directions. The other really interesting thing is if you think about kind of flipping that graph over, so negative square root of x. Oop, I didn't get my square root button. Get it. X. Too many x's now. You get that, but flipped down. So a couple of things to think about there. First of all, a negative outside will flip it over, and now it is going to the right still, but now it's going down, but it still has that strict starting point. But if you think about it, this entire graph together just looks like a sideways parabola, which is really cool because if you think about it, a square root is just the opposite of squaring, and so hopefully it kind of makes sense that this graph should look like a parabola just turned to the side like that. So that's kind of a fun thing. Okay, so if I kind of have my starting graph right here, we want to take a look at how adding or subtracting some numbers might change that graph. So if I put in my square root function, and maybe let's take a look at if I add or subtract something inside. So let's say we got x, and then let's say we do plus 3. And so it's really important to notice like same graph, and it actually is moving at the same speed. Like we have this first point here that's at 0, 0, and the next nice point that I come to is at 1, 1 right there, right? It's right there. So that's kind of how fast that graph is going, 0 and then to 1, 1. This graph is also going that fast because it starts here at negative 3, 0, and the next point it gets to is 1 away and 1 up. Okay, so it is at negative 2, 1 right there. So it's still going the same speed. I know it kind of looks like maybe it's going faster or slower, but I think all that really happened is it got moved back 3. So if I take a look at a similar thing, but now let's subtract something, so we'll do x minus 2. Same graph except for now it's starting at 2, 0, and it's still moving that same speed because it does get 3, 1, which is 1 over and 1 up. So still 1 away, so still going that same speed. So seemingly anything that gets added or subtracted inside is moving me left or right across the x-axis, but opposite, right? So like here I see a plus 3, but it goes to negative 3, and here I see a minus 2, but it goes to positive 2. So hopefully that makes sense and goes along with all the other graphs that we've graphed. So now let's say we take our square root function, but we do some stuff on the outside of the function. So we have square root of x, but then I go outside the square root, and let's like do plus 3. Okay, so we have a new graph here, still going the same speed because it's starting here and then it goes 1 away at 1, 4. So starting at 0, 3, and then it does go to 1, 4 right there. So it's going the same speed as that graph. The speed didn't change. It just got shifted up. So it moved up 3, and now it's starting at 0, 3, and still going up and to the right. And so then if we try taking our square root function and go outside of that and subtract 2, we end up same graph, but moving it down 2. still going one away. Okay, so hopefully that makes sense. So like kind of if I'm doing stuff inside, I'm going to move left or right. Oppositely, if I'm doing stuff outside, adding or subtracting outside the function, I'm moving up or down. Now the only other thing we might consider is if stuff is being multiplied to that, and we kind of tried one already where we multiplied by a negative and that kind of flipped me over. But I wonder what happens if I like times by 3 in front of it. So 3 times the square root of x like that. So it's still starting at 0, 0, which hopefully kind of makes sense because I didn't add or subtract anything. But the next nice point that I get to is where? Like where? Oh, right here. That's where it's crossing. Really nice point. So at 1, 3. So it went over 1, but it didn't go up 1 now. It went up 3. So it seems like that 3 is kind of doing that. And so maybe if we try another one like y equals 2 and then square root x, we get this green graph here. Still starting at 0, 0, but that next nice point is going through right here, which is at 1, 2. So it went over 1 but up 2. So it seems like maybe this number in front is kind of making me faster or slower. Well, right now just faster, but I wonder if I can't get it to go slower. And so if I try maybe a fraction, that'll make me go slower. So square root x, because the negative just flipped me. And so yeah, here is kind of our base function, and now this is going slower than that because it's kind of under it. And so the next nice point is right here. It's over 1, but it's only up half. So this number out front is kind of like our slope, but it doesn't like go up 1 over half again. That's the interesting thing. So like from here to here on this base function, like we go up 1 over 1 when I have a number 1 in front. So on that red function we have a 1 in front. But if I go up 1 over 1 again, I don't get another point on the graph. And note that this graph is counted by 2, so that's kind of why I did that. Same thing with your green graph. So the green graph had a slope of 2. So from this starting point, I went up 2 over 1 to get to a point. But if I go up 2 over 1 again, I don't get to another point. So this slope only works once. I can't use it over and over and over again. Okay, so hopefully that kind of helps. We're going to maybe take a pause from Desmos and talk about our square root functions in our notes. And then we'll go back and talk about the cube roots. So we got this note sheet here for us. I hope I have a pen somewhere. I do. So here's our square root function. And we talked about all these different letters and what they do. So the shape of the graph is always going to look like this, where we kind of have this strict starting point and we go up and to the right. If A is positive, but remember we made it negative, and so it could start here and go down as well. Now there is cases where it could go backwards, but we're probably not going to see those, and that's okay. In addition to being like positive or negative, A was that number out front that we were just looking at, so that's also kind of like a slope number, but only for 1 point, so I can only do it once. So slope only once. I can't keep doing it over and over and over again. Okay. Now H was that number inside the square root function. I can tell because it's got that long bar over it. And when we were adding or subtracting numbers inside there, we were moving left and right, but oppositely. So like if I see minus 2, I really go to positive 2, or right 2. Or if I see minus 3, or no, I just said minus. If I see a plus 3, then I'm going to go back 3 or negatively 3. Sorry, my cat just came in here and freaked me out. And then K on the outside right there, if I add or subtract something outside, that was moving me up or down. And it did exactly what it said. Like if I saw a plus 3, I went up 3. If I saw a minus 2, I went down 2. And we don't have to worry about domain and range. That's okay. So 2 quick examples here. Looking at this one, I can tell that this graph is going to move right 1 because this number is inside, and inside moves left or right but opposite. So since I see a minus 1, it's actually not going to go to the left one, it's actually going to go to the right one. So I kind of always start at 0, 0 because that's where that base function starts, but then I'm going to shift it all to the right 1, and that's going to be my starting point. Now it also has a slope of 1 because there's no number outside, so that's kind of like 1, which means that from that point I can go up 1 over 1 to get another point. But then I can't do it again because I can only do my slope once, but that kind of gives me an idea of like which way my graph is going. And also it's positive, so it makes sense that it should kind of look like that shape. And that's really it. Now when we start adding lots of numbers in there on this example, we might have to think about it a little bit more slowly because I can see a lot of things happening here. Like if I go through the numbers in order, that first number 2, because it's being multiplied in front, that means I have like a slope of 2, which means it's being stretched out, like it's getting taller because it's going to go faster. The next number I see is a +1 inside, so inside moves left or right, but opposite. So it's not going to go to +1, it's going to go to -1, so left 1. And there's a number outside being subtracted, which is up and down, so I'm going to go down 4. So you always start at your base of 0, 0. And you need to shift first. So I have to do slope last, so I'm going to go left 1, down 4, and put my starting point. And then from there, I'm going to do my slope of 2, so I'm going to go up 2 over 1. But I can't keep going because you can only do slope once. And now this graph only goes in one direction. It starts at that starting point and goes through your slope and continues in that direction. So this one is going up and to the right because it was a negative. And don't worry about domain and range. So hopefully that feels good and makes sense. It's a lot like the other graphs that we've done. And actually let's go back now and try cube roots. So a cube root base function has nothing changed to it, and you can actually bring that up on here too, like if you click the functions button and you want to go over to miscellaneous, I think, yeah, right here we can pick n root. So if we go there and then it puts you kind of up in the little index, you can put the 3 right there, and then we're just going to do our base, so nothing has changed to it. Look at that thing, oh my god, it's a weird little swiggle S, like a stretchy S. And unfortunately, we didn't get to graph cubics before we left on this, pandemic break. And you would notice that if I take x and cube it, so to the 3rd power, it's like that graph just turned. So like a parabola and then a square root function. So if we take a look at some of the things we were working with our square root function and see how it changes here, if I take my cube root, which I'm just going to copy and paste so I don't have to do that little function over and over every time. If I go back in there and we try adding and subtracting stuff inside, so let's say we do, I don't know, -4. Okay, so my whole stretchy S right here just got shifted over to the 4 spot, and like this point in the center here right at 0, 0 is pretty important because like this graph is kind of going up and then like flattens out right at 0, 0 and then kind of goes the other direction right there, so that's a pretty important point. And so if you notice, that whole point got shifted to the right 4, but the graph is still doing the same thing, still doing that stretchy S thing. And so if we try it again, but now let's go in there and maybe add 1. So that took that whole stretchy S and kind of pushed it back 1. Now the slope's not changing at all because I can see right here I start at 0, 0 and the next point that I go through that's really nice is 1, 1 right there. Same thing here. So this one is starting at -1, 0, so it got pushed back that 1. And the next nice point that it goes to right there is 1 away, so it went up 1 over 1 to get there. So it's doing like that same stuff that the square root was doing, it just has a different shape. Okay, so if we take a look now at maybe doing some stuff on the outside. So now here, and we're going to like add 5. Stretchy S, all the way up there, starting at 5. And the next nice point is up 1 over 1 away, so it's still going the same speed, it's just the whole graph got pushed up 5. And so then if we take this again and let's maybe -2, stretchy S got pushed down 2. And like it's still going the same speed because it's up 1 over 1 away. Okay, so now the last thing to kind of consider is if we multiply a number. So if we kind of take here, let's first just try our negative. Okay, so we have this stretchy S that is kind of like slowly going up and then speeds up, kind of levels out in the middle there, and then flips and turns the other direction. Now if I put a negative in front, it just does the total opposite. Kind of starts up and goes down, still flattens out at that 0, 0, and then like flips and turns the other direction. Okay, so that's the negative, which we're going to want to keep in mind. But let's see what happens if I multiply like a number in front. So let's maybe multiply by 2. Okay, so we have our stretchy S. Now the multiplied by 2 one, the blue one right there, still doing the stretchy S thing, it's still at 0, 0, but it kind of got taller. And if you look at it, so the black one went up 1 over 1 to get to another nice point. The blue one, which is the one I times by 2, if I go up 2 over 1, I get to the next point. And this one actually goes in the other direction, so if I go down 2, back 1, I also get to a nice point. So it seems like the same thing is happening here that happened with the square root. The number in front is kind of like slope. So if I take this one and maybe multiply by a fraction, so like a fourth, let's get rid of that blue because this is kind of a confusing thing to look at. Still stretchy S. Maybe if I zoom in a little bit we can see better. It's still doing that like flattening out thing in the middle, still at 0, 0, but kind of the next nice point, if I go 1 away right here, that's at a quarter, which is a fourth. So that thing out front is kind of like slope. Now it's not like rise over run slope, it's like if I go up a fourth and over 1 I get to a point, which we've done that before too. So let's push this down and take some quick notes over here. So we have our cube root function. Now the shape, when you are positive, kind of started down, did that little flattening out thing, and then ended up like that. Now the negative one just does the opposite, so it kind of starts up, flattens down, and ends up down like this. So they're just the reflections of each other. Kind of like to call it the stretchy S shape. But A could also be that slope, so just like with our square root, but we could only do it once. H was still moving me left or right, so it's doing the same thing as the other one, and it was opposite, so left, right, and it's opposite. And then that number being added or subtracted outside is up and down, and it does exactly what it says it does. Like if you see +4, you're going to move it up 4 and not worry about domain and range again. Okay? Okay, so it's important to notice the index out here because the index is telling me the shape. So since it's a cube root, I know it's going to look like the stretchy S and not kind of like the, I don't know, small little hill thing. I don't know. We called it a slow dab in third hour. It was really nerdy. But I can also tell that this stretchy S, kind of in that spot where it changes direction, got moved left 2, because opposite, and down 1. Okay, which normally it starts at 0, 0, but this one got moved left 2, down 1, and so that's where the change happens, is right at this spot. So it's gonna like go back like this and over like that, exactly by a slope of 1 because there's nothing out front. So from here I can go up 1 over 1 and it kind of goes in this direction, but I can also go down 1 back 1 because this graph does go in both directions, and so then you can kind of get it to go back like this too, so you get your stretchy S. Okay, so then down here I can see each number in order and like what it's going to tell me. So that first number, because it's negative, I know this is going to be flipped over the x-axis. So it's going to kind of look like this sort of deal instead of what I had up here. It's also going to go slower because the slope is just half, a third. I can't read. It's fine. And then this next number, this -3, is telling me that I went right 3. And then that last number is telling me I went up 2. And so we always want to first start with our translation. So it always begins at 0, 0. But this one got moved right 3, up 2. And so that's kind of where the flattening out happens. Now it got flipped. So since my slope is -1/3, I can't really do rise run. I just have to go down a third, which is going to be so small on this graph, and then over 1, so that it's going kind of down like this. And because this graph goes in both directions, I can go up a third and back 1 because that will still be negative, and that gets it going in this direction. So kind of a smushed and flattened out S, but still a stretchy S. So hopefully that helps, and you guys are going to try a little matching activity after this, and then your assignment will be on Thursday where you're going to graph and show me how you did. Good luck.